Hello, in today's mechanics class, we are going to discuss a very fundamental thing or idea. So let here there is a rigid body A of mass m and which is at rest. So now let a constant force P starts acting on this body. So as the body is rigid, the force P cannot do anything than to change its state. That is why in mechanics we always take the concept of rigid body. So when the body is rigid and a force act on it, so that force only change its state and the force cannot do or anything to the body except changing its state. So initially the body was at rest. The force P makes the body to move in its direction on its line of action as shown dotted line. So here the dotted line shows the line of action of the force P. So the force P makes the body A to move along this dotted line in the direction in which the force act. So right now the acceleration produced on the body will be A equal to force by mass. We know acceleration equal to force acting on the body divided by its mass. So A equal to P by M. So now as we know the force, the acceleration which is produced on the body. So with the help of this we can find out what will be the velocity of the body at some other time t equal to t1 and time t equal to t2. So initially when time is 0, the body was at rest, so u equal to 0. So at time when time t equal to 0, initial velocity u equal to 0. So at some time t equal to t1, the final velocity v will be equal to u plus at. U is the initial velocity and a is the acceleration and t is the time. So when body is at this point at time equal to t1, the velocity here which is v1 will be 0 plus p by m into t1, which is p by m into t1. Similarly, what displacement the body will cover during this time t1, which is here marked as s1. So at time t equal to t1, displaces s1 equal to u t1 plus half a t1 square. So s1 equal to 0 into t1 plus half p by m t1 square, which comes out to be half p by m into t1 square. Similarly, at some time other time t equal to t2, so at time t equal to t2, final velocity v2 will be u plus a t2, which is equal to 0 plus p by m into t2 and which comes out to p by m into t2. So similarly at time t equal to t2, displacement s2 equal to u t2 plus half a t2 square, which is equal to 0 plus 0 into t2 plus half p by m into t2 square, and it comes out to be half p by m into t2 square. So in this way we can predict the velocity and displacement covered by the body in any future time t. In any future time we can find out where will be the body, and that means what will be the displacement covered by the body and what is the velocity at that time. So when the force P and the mass of the body are given to us, so with the help of this mass and the force acting on the body, we can predict what is the displacement of the body and what will be its velocity in some future time. So here we have talked about this body which is initially at rest. In the future lecture we will see what will be the velocity and displacement covered when the body initially has some initial velocity. So let us meet in the second video.